Welcome to the Deep Dive. This is the show where we really get into the weeds. We take a whole collection of the best insights on a really critical subject, and we pull out those, potent nuggets of knowledge, all custom tailored just for you, our listener. Today, we're plunging headfirst into something foundational for anyone working with databases. But surprisingly, it's often misunderstood. We're talking about a pragmatist guide to SQL Server isolation levels and locking hints. Headed right. Our mission here, to really shortcut your journey, help you get truly well-informed on a topic that can, well, frankly, make or break your database performance and your data integrity. Here on the Deep Dive, our focus is squarely on databases, data engineering, and architecture, and it's all powered by the incredible capabilities of AI.
And that's exactly why this stuff is so critical for you, the cloud database professional. Getting these concepts wrong, or worse, actually misusing them, that can lead to really significant performance hits. And not just slow performance, but subtle data inconsistency bugs, the kind that are notoriously difficult to track down, especially in systems with lots of users hitting it at once. It's not just about getting data out right, it's about getting the right data consistently, efficiently, and doing it without crippling your system's ability to handle maybe thousands of simultaneous users. It's a balancing act.
Absolutely. And this isn't just, for the hardcore DBAs either, this deep dive. It's really for everyone. Junior developers may be tempted by that quick fix, like slap an NOLOCK on everything, but also experienced DBAs, data engineers, architects, application developers, all of us. We're going to go beyond those dry textbook definitions today. We want to give you a truly practical understanding, something you can actually use. And speaking of staying ahead, we bring you new insights like this every single week. So make sure you hit that like button, subscribe, follow us. You don't want to miss out.
Indeed. And you can think of us, your hosts, as your AI personal assistants. We're here working alongside humans, specifically helping you, Alex, Rosa, and really everyone in the data community to speed up that learning curve, which, let's face it, is pretty necessary these days. Technology is just moving so incredibly fast.
It's that full circle, isn't it? It's actually fascinating when you think about it. Humans answer the tough questions. AI comes back with these incredibly detailed, nuanced answers. Humans assign tasks. AI personal assistants execute them with, precision. And then it closes the loop. Humans and AI assign tasks to each other, creating this amazing feedback for faster learning, better problem solving, just continuous improvement in everything data. It's truly transformative. Now let's get into the core of today's deep dive. Let's focus on the real database and data engineering aspects, the impacts, the trends, the opportunities tied up in this critical topic. Okay, so let's unpack this core challenge. It's something every cloud database professional hits sooner or later. In SQL Server, well, really in any relational database, you've got this constant kind of delicate balancing act. On one hand, you want high concurrency, lots of users, lots of processes, all hitting the data, reading, writing, doing things simultaneously. But on the other hand, you have this absolute non-negotiable need for data consistency, integrity. Making sure the data is correct, reliable, trustworthy. Even when 1,000 things are happening at once, transaction isolation levels and locking hints, these are the main tools SQL Server gives us to manage that balance. It's a powerful toolkit, definitely. But as we're about to find out, it comes with a lot of responsibility and some hidden complexities.
Exactly right. And the temptation is always there, isn't it? Especially when you're chasing performance. You see hints like NOLOCK and think, I'll go faster switch. Or maybe you just stick with read committed because, well, it's the default and you don't really think deeper about what that means. But that approach misses a whole world of nuance. It's almost a philosophical difference in how you interact with the database. Misusing these tools, it doesn't just slow things down sometimes. It can lead to these incredibly insidious bugs, really hard to catch. They often only pop up during critical month-end reconciliation or something. We're talking things like dirty reads, where you see data that might just vanish because it gets rolled back. Or non-repeatable reads, where the data changes right under your feet in the middle of a transaction. Or phantom reads, where suddenly new rows appear in a result set you thought was stable, and then the flip side is just as bad, creating severe performance bottlenecks through excessive blocking. One operation just grinds everything else to a halt. Frozen applications, unhappy users, you know the drill. So our goal with this deep dive is to give you, the cloud database professional, the practical implications, the understanding you need to make informed decisions that balance both performance and correctness. It's about moving beyond just making things work to making them work right. Every time.
That's such a crucial distinction. Not just fast, but accurate under pressure. So to really dig into this, we have to start with the foundation, right? Understanding transaction isolation levels. The ANSYSO SQL standard lays out 4 main ones. And SQL Server, being SQL Server, adds its own specialized versions, which are, frankly, incredibly impactful. Each level gives you a different trade-off. more concurrency versus more consistency. It's like turning a dial, but you absolutely need to know what turning that dial does to your data, to your whole system. So let's break them down, what they mean in practice. Maybe start with the most lenient one.
Precisely. Let's go through each one. Not just the definition, but the real-world impact. And yeah, often the hidden dangers. 2.1, read uncommitted. Okay, so what is it? This is the absolute loosest level you can get. For a lot of developers, it's basically the same thing as sticking NOLOCK on your select statements. When a transaction runs at read uncommitted, it's telling SQL Server, look, I don't care if the data I'm reading is committed or not, just give it to me now. It essentially bypasses the usual shared locks. It can read data that another transaction is actively changing, even if that change hasn't been finalized with a commit. Phenomena allowed. Because it's so loose, yeah, it allows all three classic concurrency problems. Dirty reads, non-repeatable reads, and phantom reads. All fair game here. So a dirty read that's reading data that gets rolled back later, it never officially existed in a committed state, like seeing a mirage, you know? Non-repeatable reads run the same select twice in one transaction. You might get different results if someone else committed a change in between. And phantom read, new rows appear or disappear in your result set between reads because another transaction inserted or deleted rows matching your filter. The risk. Okay, this is the big one. The potential for reading dirty data is incredibly high. And this is where NOLOCK often leads to disaster, even if it seems subtle at first. Imagine your app reads, say, an inventory count using NOLOCK. Then it makes a critical business decision, approves a big order, but, the original transaction that was updating that count, it rolls back. Maybe due to some other error. Your decision was based on data that technically never existed. You just approved an order for stuff that isn't there. You can see how this could be catastrophic, right? Financial systems, inventory, anything needing accuracy. It feels like a quick fix for speed, but you're trading that speed for potential data corruption. It's a bad trade. When to consider it? With extreme caution, honestly. Almost never. Use this with extreme caution. The source material suggests maybe for huge, mostly static reporting tables, where approximate data is okay and blocking is absolutely forbidden. But even then, we and the source strongly recommend that snap-t-shot isolation is almost always a much better, safer choice. It gives you similar blocking reduction, but without that dirty read risk. It's like driving fast with airbags versus no seatbelt. Action proposed for the cloud database professional. Seriously, question any use of NOLOCK or read uncommitted. If you're using it to solve blocking, you're probably just masking a deeper problem, and you're inviting data inconsistency that will bite you later. To fix reader-writer blocking, look at enabling read-committed snapshot RCSI at the database level instead. It's nearly always the better, more robust, safer way to go. 2.2 read-committed. The default. Okay, what it is. This is SQL Server's default setting, the one you get if you don't specify anything else. And it's a big step up from read uncommitted. Its main job. Preventing dirty reads. It makes sure your statement won't read data that's been changed but not yet committed by someone else. How? Well, it takes shared locks on the data while it's being read. So if a writer has an exclusive lock on a row you want to read, your read committed query will just wait patiently until that lock is released. Until the writer commits or rolls back. Phenomena allowed. So it blocks dirty reads, which is great. But it still allows non-repeatable reads and phantom reads. What that means is, if you're doing several things in one transaction, you select some data, then another transaction updates that same data and commits. And then you select it again within your original transaction, you'll see the new committed value. The data you see is always committed, yes, but your view of it isn't necessarily stable for the whole duration of your transaction. The problem, that non-repeatable read is the key issue here. Imagine building a complex report. First, you query the total order value for a customer. Then, later in the same report generation, you query the individual order lines. What if, between those two steps, someone updates one of those order lines and commits? Your total might reflect the old value, but your detail list shows the new one. Suddenly, your report is internally inconsistent. That can be a real headache for things like auditing or precise financial reconciliation. It's like trying to count something while it's moving. Action proposed for the cloud database professional. Understand that read committed is a good default for many apps. It works fine a lot of the time. But it's not a magic bullet for every concurrency problem. Be really aware of its limits, especially non-repeatable reads and phantoms, particularly for analytics or financial stuff where you need that transactional consistency across multiple reads. For those critical multi-statement transactions needing absolute consistency, you might need to go to a higher level, 2.3 repeatable read. Okay, what it is. Moving up the consistency ladder, repeatable read is stricter than read committed. Its specific goal is to fix that non-repeatable read problem we just discussed. How does it do it? By holding shared locks on all the data it reads, but for the entire duration of the transaction, not just for the single select statement. So if your transaction reads a specific row, no other transaction can change or delete that row until your repeatable read transaction finishes. It gives you a stable, unchanging view of the rows you've already touched. Phenomena allowed. This level successfully stops dirty reads and non-repeatable reads. Good. However, it still allows phantom reads. The impact. The guarantee is pretty strong. Reread data in the same transaction, you're guaranteed to get the exact same values for those rows. They won't change. But, and this is the key subtlety, another transaction can still insert new rows that happen to match your where clause. So if your transaction selects all widgets over $100, then someone else inserts a new widget, also over $100. Your next select in the same repeatable retransaction will see that new phantom widget. So your view of the set of data can change, even if the individual rows you already read are stable. See the difference. And because it holds locks for longer, this level definitely increases the potential for blocking compared to read committed, significantly. Action proposed for the cloud database professional. Use repeatable read when you absolutely must ensure that data you've already read stays unchanged for your whole transaction. But be super aware of the increased blocking and the phantom read potential, which can be tricky to debug. Test thoroughly for concurrency issues like blocking, especially under high load. You're trading some concurrency for stronger read consistency. It's a conscious choice. 2.4 is serializable. Okay, what it is, this is the top dog. The most restrictive ANSI isolation level. And it really lives up to its name. Serializable tries to make concurrent transactions behave as if they ran one after another in perfect sequence, serially. To do this, it holds locks until the transaction completes. It stops others not just from updating or deleting rows you've read, but also from inserting new rows that would affect your transaction's results. It provides the highest level of consistency in the traditional locking model. Phenomena allowed. None. Zip. Nada. When you run it serializable, you're guaranteed. No dirty reads, no non-repeatable reads, and no phantom reads. It's like your transaction gets a completely isolated, static snapshot of the data for its entire life. How does it prevent phantoms? It uses not just row or page locks, but also range locks. Think of it like reserving a block of seats in a theater.
Don't miss out. Smash that like button, subscribe, and explore our other videos in the playlists.